Howdy, folks. Welcome back. We are on to part two of slope. Let's begin with a little bit of a review. A line segment is shown to the right. The dependent variable is, well, y. The independent variable is x. The rise is the change in the dependent variable, which is the change in y. The change is denoted by delta y. Use the graph to find the rise. So I start at one of the endpoints. 1, 2, 3, 4. That's plus 4 rise. The run is the change in the independent variable, which is the change in x. This change is denoted by, when I say change, it should be delta y. And then likewise, delta x. Use the graph to find the run. So from here, 1, 2, 3, 4, 5. That's a plus 5 run because I'm going to the right. And so that is a plus 5 run. State the coordinates of the endpoint. So A is at, that's 3, 2. And B is at 8, 6. 3, 2, and 8, 6. 3, 2, 8, 6. Using only the coordinates of the endpoints and not the graph, how can you calculate the rise? So the rise, so this is x, y. Let's call it x1, y1, x2, y2. So the rise, I'm just taking the y coordinates. So the rise is the rise is y2 minus y1, and that is 6 minus 2 equals a plus 4. Got that? Using only the coordinates of the endpoints and not the graph, how can you calculate the run? So the run we know is the horizontal or the x values. So that's x2 minus x1. And that is 8 minus 3, and that's what we got, plus 5. Awesome. For the points, P1, x1, y1, and P2, x2, y2, write an expression for the rise. Rise is symbolized by delta y, change in the y values. That's y2 minus y1. Write an expression for the run, symbolized by delta x, change in the x values. x2 minus x1. Write an expression for the slope. Well, I'm going to divide these two. So the slope equals m equals rise divided by run equals the change in y, and that's delta y divided by delta x equals y2 minus y1 over x2 minus x1. And this is the formula for the slope on your formula sheet. Slope equals y2 minus y1 over x2 minus x1. This entire lesson, we're going to use the slope formula to calculate slopes. Let's go. Next page. Use your slope formula to determine the slope of the line passing through E, negative 3, 6, and F, 5, 2. So before we do this, I want to suggest using brackets, because when you apply the slope formula, when you use the slope formula for any 2 points, you are in essence making a mathematical substitution process, right? So you're substituting values. So use brackets, and you'll see why when we do negative values later, where it comes in handy. So first, the slope equation. Slope equals y2 minus y1 divided by x2 minus x1. Substitute the values in. So what I like to do is I go x1, y1, x2, y2. So I know exactly which values to pick. y2 is 2 minus y1, which is 6, divided by, I'm going to say use parentheses just for the second value. So y2 is 2 minus y1, which is 6, divided by x2, which is 5, minus x1, which is negative 3. Okay, notice I use parentheses there, or brackets, because sometimes kids do this. 2 minus 6 over 5. Oh, it's a negative 3, so you just go like this. But this is not the same as this. That's 5 plus 3 versus 5 minus 3. That's why I use brackets. Okay, so let's back all this up. All right, so it's 2 minus 6 over 5 minus negative 3. Evaluate, that's negative 4 in the numerator. 5 minus negative 3, that's 5 plus 3. And that's negative 4 over 8, otherwise known as fully reduced negative 1/2. So the slope is negative 1/2. Use the same coordinates to show that the order in which you subtract the coordinates does not matter. So if I have E, let me just write it like this. Oops. Negative 3, 6, and F, 5, 2. Let me go x2, y2, x1, y1. Let me just swap those. And then let me show you that it doesn't matter which way you go. So y2 is 6, y1 is 2. So you notice we're reversing that numerator, and then we're going to reverse the order in which we subtract the denominator. x2 is negative 3 minus x1, which is 5. That is 4 divided by negative 8. That is otherwise known as negative 1/2. So the order in which you subtract the coordinates does not matter. You get the same result, same slope. Use the slope formula to determine the slope of the line that passes through each pair of points. So let's do a whole bunch of practice problems where really the hardest part here, or the trickiest part, is the negative numbers and making sure that we account for them. So I would suggest use brackets. So first the slope formula. And then I do this to help myself out. x1, y1, x2, y2. I always label. You don't have to do it, but I find that it helps. That's negative 4 minus y1, which is 7, over x2, which is 6, minus x1, which is negative 2. That's negative 11 over 8, and that's it. Let's label x1, y1, x2, y2. Okay, and then I get y2 is 10, y1 is negative 5, x2 is 8, and x1 is 3. That's 10 minus negative 5 is 10 plus 5, that's 15. 8 minus 3 is 5, and that's a slope of 5. Oh, no. Oh, man. That's a slope of 3. Sorry about that, folks. Okay, label x1, y1, x2, y2. Okay, there's a slope formula. Slope equals y2 minus y1, negative 4 minus 6, use brackets. x2 is 5 minus x1, which is 9. That's negative 10 divided by negative 4. That's also a slope of 5/2. Letter D. Well, use let's label that. And then here's the slope formula again. y2, negative 8 minus y1, 7, over x2, negative 2, minus x1, x2 is negative 3 minus x1, negative 3. That's negative 15 over negative 3 minus negative 3 is negative 3 plus 3, that is 0. Well, dividing by 0, that is an undefined slope, folks. Undefined. Okay. How about 2, negative 7, and 7, negative 7? Okay, for an undefined slope, did you notice that the x-coordinates were the same? Okay, so if I'm thinking about this, let's just briefly sketch it out, x and y. It passes through -3. It's going to be, here are your 2 points, right? That's a vertical line, so that's going to be an undefined slope. How about this next one? What do you suspect is going to happen? I have the same y coordinates this time, right? Before we draw it, let's just calculate the slope. Here's our slope formula. And then I'm going to label it x1, y1, x2, y2. Okay, I can barely see that. What's going on here? That's y2. y2 is -7 minus y1, -7, over x2, that's 7 minus x1, 2. Well, look what's going on in the numerator. That is -7 minus -7, -7 plus 7. That's 0 divided by 5, and that equals 0. So does that make sense? 0 means horizontal line, right, folks? So what if I draw this out? What's it going to look like? Oh, come on. Give me a black line. There we go. All right. Well, if we plot these 2 points, 2, -7, let's say that's -7, 2, -7, and 7, -7. That's a horizontal line, folks, so it makes sense that it's a 0 slope. Alrighty. Okay, let's make a couple statements about our first couple calculations here. If the slope of a line is undefined, it is a, you guessed it, vertical line in which which coordinates are the same? The x coordinates are all the same. If the slope of a line is 0, it is a, well, you guessed it, we just did it, horizontal line in which the y coordinates of the points are all the same. So we see the y coordinates are the same. Y coordinates are all the same. Okay, next page. Recall that, let's do a couple of applications here. Recall that if P, Q, and R are collinear, then slope of PQ equals slope of QR equals slope of PR. Use this to determine whether or not the following points are collinear. Note that you only have to show that 2 of the slopes are equal. So I'm going to do this. Check that. Okay, so if slope of DE equals slope of EF, then D, E, and F are collinear. So let's check. Let's calculate slope of DE. So DE, if I go x1, y1, x2, y2, that is 2 minus 4 over 0 minus -4. That's -2 over 4, or otherwise known as -1/2. Let's check the slope of EF. So EF, let me say that's x3, y3. So I go -1 minus 2 divided by 6 minus 0. Slope of EF equals -1 minus 2 is -3 over, that should be, let me write this neater. That is -3 over 6, also known as -1/2. Let's make a statement. Since slope of DE equals slope of EF, points D, E, and F are collinear. Remember, collinear means that all 3 points lie on the same line. Next one, J, K, and L. Let's make a statement, entering statement. If slope of JK equals slope of KL, then J, K, and L are collinear. Let's check. What's the slope of JK? x1, y1, x2, y2, that's x3, y3. So let's go JK, that is 4 minus 9 divided by 1 minus 5. Slope of JK equals negative 5 over negative 4, and that equals 5/4. Let's check slope of KL. That is 1 minus 4 over negative 2 minus 1. Slope of KL is negative 3 over negative 3, and that is the slope of 1. Let's make a statement. Since slope of JK does not equal, so 5/4 and 1 does not equal slope of KL, I can say this: points J, K, and L are not collinear. Not collinear. All right, so using our slope formula to prove or disprove collinearity. Another one, 4, A, B, and C, points A, B, and C, determine the slope of AB. Okay, where are we going with this? We got this point C has a variable x. We'll get to that a little bit later. Determine the slope of AB. x1, y1, x2, y2. Negative 3 minus negative 4. Oops, let me start with the slope formula. Sorry, folks. y2 minus y1 over x2 minus x1. Okay, and then that equals y2 is negative 3 minus y1, which is negative 4. x2 minus x1, 5 minus 2, and that's negative 3 minus negative 4 is negative 3 plus 4, that's 1. 5 minus 2 is 3. So the slope is 1/3. Slope of AB is 1/3. Write an expression for the slope of BC. So let me just write BC again. So B is 5, negative 3, and C is x1. So that's x1, y1, x2, y2. So let's make an expression for the slope. y2 is 1 minus x1, or sorry, y2 is 1, y1 is negative 3. 1 minus negative 3 over x2 is just x minus x1, which is 5. 1 minus negative 3 is 1 plus 3, that's 4, over x minus 5. If A, B, and C are collinear points, what can you say about the slopes of AB and BC? The slope of AB must equal the slope of BC. Okay, use your results from part A to C to determine the value of x. So if the two slopes must be equal, then I can make this statement. 1/3, that's the slope of BC, must equal slope of BC, which is 4 over x minus 5. Let's determine the value of x. So remember this trick, I can cross multiply. So cross multiply that way. So like that. So that's 1 times x minus 5, and then cross multiply the other way, equals 3 times 4. That's x minus 5 equals 12, Add 5 to both sides, that's x equals 7. Oops. Oh, 17. Sorry about that, folks. X equals 17. We can check this real quick, too. Remember points B and C? B is 5, negative 3. And C, we said is x1. Now we know it's 17 and 1. Right? So 17 and 1, that's what we just calculated. 17, 17. Okay, let's use our slope formula and just calculate slope of BC from the actual values. So x1, y1, x2, y2. That is 1 minus negative 3 over 17 minus 5. That's 4 over 12, and that's 1/3. Is that what we should have? Yep, 1/3, 1/3, and that's a check. Number 8, determine the value of y if D, E, and F are collinear points. Okay, if D, E, and F are collinear, that's what we say, the slope of DE must equal the slope of EF. So let's calculate the slope of DE first. x1, y1, x2, y2. That's 0 minus 4. 0 minus 4, 6 minus negative 2. That's negative 4 over 6 minus negative 6 plus 2. That's 8. That's negative 1/2. And let's hold on to that for a bit. Let's calculate the slope of EF in terms of y. So E is 6, 0. F is 8y. That's x1, y1, x2, y2. So the slope of EF is y minus 0 over 8 minus 6. Slope of EF equals y over 2. Okay, this statement, we said the two slopes are equal. Therefore, we can take all this and say negative 1/2 equals negative 1/2 equals y over 2. Y over 2. This negative 1/2, I'm going to say it's a negative 1 over 2. Cross multiply. That's negative 1 times 2 equals 2 times y. That's negative 2 equals 2y. Divide both sides by 2. I get negative 1 equals y. Next page. Determine the missing value if the line segment joining the given points has the indicated slope. Slope of AB equals y2 minus y1 over x2 minus x1. So you can label it, or let's try to do this without labeling. Okay, so slope of AB equals y2 is 6 minus y1, which is 2. x2 is x minus x1, which is negative 1. Slope of AB equals 4 over x plus 1. Well, we said the slope is 1/2, so I can make an equation. 1/2 equals, so 1/2 equals 4 over x plus 1. Cross multiply. 1 times x plus 1 equals 2 times 4. That's x plus 1 equals 8. Subtract 1 from both sides. I have x equals 7. G and H, and a slope of negative 2/3. So the slope of GH equals y2 minus y1 divided by x2 minus x1. Slope of GH equals 4 over negative 2 minus x. Well, the slope of GH is negative 2/3. Negative 2/3. Let me say negative 2 over 3. That's 4 over negative 2 minus x. Cross multiply to solve. That's negative 2 times negative 2 minus x equals 3 times 4. That's 4 plus 2x equals 12. Subtract 4 from both sides. That's 2x equals 8. Divide both sides by 2. X equals 4. Last one, Q. find the slope of PQ equals y2 minus y1 over x2 minus x1. Slope of PQ equals 6 minus y over 4. Well, the slope of PQ is just 2 over 1. And that equals 6 minus y over 4. Cross multiply, that's 2 times 4 equals 1 times 6 minus y. That's 8 equals 6 minus y. I'm going to subtract 6 from both sides. I have 2 equals negative y. Remember, I want to solve for y, not negative y. I'm going to divide both sides by negative 1. That's negative 2 equals y. Next one, a line segment with a slope of negative 1/2 has one endpoint at 0, 4. If the other endpoint is on the x-axis, determine its coordinates by graphing. Interesting. I'm going to go like this, negative 1 over 2. So I know how to do my rise over run, because I'm going to do this graphically. One endpoint at 0, positive 4. So I go 1, down 1, negative 1 rise, positive 2 run, 1, 2. Let's see, 1, 1, 2. I'm hoping this hits the x-axis. 1, 1, 2. 1, 1, 2. There it is right here. That's 8, 0. By graphing coordinates on x-axis is 8, 0. How about the slope formula? On x-axis means y equals 0. So my coordinates can be represented as x, 0. But what is this x value? So my 2 points are, well, 0, 4 and x, 0. And we know that the slope is, yeah, they gave it to us, negative 1/2. So I'm going to develop a slope m equals 0 minus 4 over x minus 0. And that's negative 4 over x. Well, we know that equals negative 1/2. So I make this statement, negative 1 over 2 equals negative 4 over x. And I cross multiply. So negative 1 times x equals 2 times negative 4. That's negative x equals negative 8. Divide both sides by negative 1. X equals 8. And bingo, that's what we got. That's the x value right there. So that checks. Okay, number 11. Algebraically determine the slope of a line that has an x-intercept of 4 and a y-intercept of negative 6. Remember, x-intercept of 4, that's where y equals 0. Remember the definition of an x-intercept? That's where y equals 0, so that's a coordinate of 4, 0. Likewise, a y-intercept of negative 6, that's where x equals 0, so I have a coordinate of 0, negative 6. Determine the slope of a line. Well, just use a slope formula. Sometimes when we look at intercepts that are given, we're like, oh, I don't have complete information. When I'm given an x-intercept, I don't know what the y-coordinate is, but you do know what the y-coordinate is. For an x-intercept, the y-coordinate is 0. Likewise, for a y-intercept, the x-coordinate is 0, so you do have a lot more information than appears to be, right? So x1, y1, x2, y2. Negative 6 minus 0 over 0 minus 4. Negative 6 over negative 4. and then that slope is 3/2. Well, let's just take a look. Let's just draw this out. 0, -6. 1, 2, 3, 4, 5, -6. And 4, 0. 1, 2, 3, 4, 0. And let's draw a line through it. Does it look like a slope of 3/2? Well, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Rise over run. 6 over 4. And that, folks, equals 3/2. So 3/2, check. All right, we're done with slope part 2. So hopefully these two introductory lessons, or actually part 1A, 1B, will be a good lead in for our next lesson coming up. Get lots of practice in. Very heavy algebraic stuff on this particular lesson. Okay, so get lots of practice in. We'll see you next time.